Defect Collection. In this animation, we are going to see about defect collection. Data collection during reviews is crucial. You have already seen that at various stages in the process, data are recorded. Because reviews are largely human processes, if data are not properly recorded, the information can easily be lost. In addition to logging the defects identified by the review process, effort data must also be captured. Detailed defect data are needed for tracking defects in the project. The overall defect and effort data are needed for analyzing the effectiveness of the review and for constructing the review capability baseline. Hence, the summary data for each review are maintained in a review database. This section describes the key forms used for data collection during reviews at Infosys. Process monitoring and audit. In this video, we are going to see about process monitoring and audit. To gain the benefits of plans and processes, projects must follow them properly. People can make mistakes, and under deadline pressures, they tend to take shortcuts or expedient measures, often failing to follow processes correctly. Audits aim to fulfill this need. The basic objective of audits is to ensure compliance with the defined process and to provide senior management with visibility into the use of processes. To ensure a reasonable degree of compliance, audits must be done regularly. Formality ensures that personnel equations do not play a major role and that senior management gains visibility into process compliance through summary audit reports. Who should conduct the audits? Ideally, the auditors should understand the processes of the organization and their importance, and should have the necessary maturity and stature to be able to assess the implementation on a project objectively. The auditors also need to be trained in the process of auditing. Every month, the audit coordinator announces an audit schedule that specifies which project is to be audited by whom and the focus area for the audit, that is, which aspect of the process the audit should focus on. A team of 2 people normally conducts the audit. Defect analysis and prevention. In this video, we are going to see about defect analysis and prevention. Defect prevention aims to learn from defects found so far on the project and to prevent defects in the rest of the project. As discussed in before, defect prevention activities are usually done twice in a project, once when about 20% of the modules have been coded and unit tested, and again when 50% of the modules have been coded and unit tested. The main tasks of defect prevention are to perform Pareto analysis to identify the main defect types, perform causal analysis to identify the causes of defects, and identify solutions to attack the causes. Project closure. In this video, we are going to see about project closure. The software has been delivered and installed successfully. After working long hours and weekends for many months on this project, the project manager and his team have a sigh of relief that this is not a very successful project that is finished. But did the project manager learn any lessons? Will he and the team members be able to avoid repeating the problems they got into in this project? If the project ends now, it is likely that the story will be repeated in another project, perhaps with minor improvements. For the project manager, the team and the organization, The project does not end until a postmortem has been done to uncover what went wrong and why, and what worked and why. This analysis will enable the project manager and the team members to cull out key lessons on project execution. In addition to helping the team members in their future projects, these lessons will also help other projects to improve their execution. A project closure analysis or postmortem analysis is a golden opportunity for process improvement that should not be missed. Indeed, this exercise is considered a best practice of software engineering. One step in the quality improvement paradigm of the experience factory is to analyze the data at the end of each project to evaluate current practices, determine problems, and so on. But despite its benefits, a postmortem analysis is not a standard activity. This section describes the contents of a project closure analysis report at Infosys and gives the closure report for the ACIC case study. Project closure analysis. Project closure analysis is the key to learning from the past so as to provide future improvements. To achieve this goal, it must be done carefully in an atmosphere of safety so that lessons can be captured and used to improve the process in future projects. Before we describe the details of the closure analysis report, we briefly discuss the role of closure analysis and its implementation. The roles of closure analysis. In this video, we are going to see about the roles of closure analysis. The objective of a postmortem or closure analysis is to determine what went right, what went wrong, what worked, what did not, and how it could be made better the next time. Relevant information must be collected from the project, primarily for use by future projects. That is, the purpose of having an identified completion analysis activity rather than simply saying the project is done is not to help this project but rather to improve the organization by leveraging the lessons learned. This type of learning can be supported effectively by analysis of data from completed projects. This analysis is also needed to understand the performance of the process on this project, which in turn is needed to determine the process capability. As noted earlier, the data obtained during the closure analysis are used to populate the process database, that is PDB. The data from the PDB can be used directly by subsequent projects for planning purposes. This information is also used in process capability, which is used by projects in planning and for analyzing trends. In earlier section, we discussed the types of data generally collected in a project and described the collection methods. The amount of raw data collected in a project can be quite large. For example, a project involving 5 people and lasting for 25 weeks will have 125 entries for weekly effort, data for about 250 defects, assuming about 0.05 defects injected per person hour, data on many change requests, various outputs, and so on. Clearly, these data will be of limited use unless they are analyzed and presented within a proper framework and at a suitable level of abstraction. Closure analysis aims to accomplish this goal. After data analysis and extraction of all lessons learned from the analysis, the results should be packaged so that they can be used by others. Packaging is the last step in the quality improvement paradigm. Furthermore, to leverage this information, project processes must be constructed so that their execution requires the effective use of data. It can be argued, however, that even if others do not learn from the packaged information, the project personnel will have consolidated their experience and will carry the lessons learned from the analysis into future projects. In other words, a closure analysis is useful even if others do not directly gain from it.